Okay, so this is a very simple quotient rule here with the function sine x e to the x. Okay, but remember you could also have like functions of sine x such as sine 3x, okay, or sine 7x and e to the x. It could be e to the 3x or whatever. Okay, so when we sort of differentiate them, we're going to need to think about the chain rule here. Okay, but in this case it's going to be really simple. You just need to remember the basic derivatives for each of these. So on top is u, so u is sine x. On the bottom then is v, and v is e to the x. So we differentiate then du by dx. Well, derivative of sine x is cos x, and derivative then of v here, dv dx, is, well, e, when you differentiate it, it stays the same, right? So you've got that there. Straight then to the quotient rule. So we've got dy dx is v du dx minus u dv dx all over v squared. So on top we've got v, which is starting top right there, which is e to the x, times cos x. Take away u, which is sine x, times dv dx, which is e to the x, okay? On the bottom, we've got e to the x for v, and we've got to square it. So now how do we square this? Well, we'll take our time, right? Because we want to square this. Let's put it in a bracket, shall we? So we'll write e to the x and bracket it and say we want to square it. Okay. Now, what I would do then on the next line is look at the top to see if I can simplify it at all. And there's nothing that will cancel, but what you might notice is that e to the x is a common factor here, yeah? So we could actually extract it out and create a bracket with e to the x as a common factor. And then you've got your bracket, okay? And then in here then, well, e to the x times, well, cos x, isn't it, to give that? And e to the x times, to give this, minus sine x. Okay, so it's quite simple. On the bottom then, we shouldn't leave this like this. We need to do a bit more work here, okay? Because it's just a single term in here. It's not like a bracket like we had in the previous examples, where if you expand it, you get more terms here. So we should tidy this up, and you just need to appreciate e to the x is e to the power x, e to the power x. So x is a power, and this is a power as well. So you've got a power raised to a power. And the rules of indices state when you've got one power raised to another power, you simply multiply them. So if you multiply them, x times 2 is just 2x. So quite simply, you write that as e to the 2x there, okay? And we can go one step further, because if you notice now, we've got a common factor here of e to the x on top and bottom, so we could actually do some cancelling, okay? So we've got e to the x here, and we've got e to the 2x here. So this e to the x would actually cancel with one of these here. So we end up with just e to the x on the bottom. Okay, just sort of using the idea of indices again. So our final answer will be cos x take away sine x all over e to the x.